Okay, so welcome to my channel. Today too, we are solving some questions on how to convert from a spherical coordinate system to from a cylindrical coordinate system to a spherical coordinate system. We have learned from our previous lessons how we prove the formulas. We have done everything. So if you've not watched the video, kindly go and watch it. We have proved all the formulas to be needed. Okay, we are done with all the essential parts. Okay, so all this one we have learned it. So I'm just solving questions and see how we can relate those formulas that we did to solve a particular question. So if you've not watched it, please kindly go and watch it. So today we are solving this question, and let's see if we can relate the formulas I taught earlier on. So this is a cylindrical coordinate system. As we can see, this is radius, this is theta, and this is z. And we are converting it to rho, theta, phi. So this is the sphere and this is the coordinate. This is the cylindrical system. So we proved this one, the relationship from my previous lessons, that rho is equal to square root of r square plus z square. So the idea is that we want rho, we want theta, and we also want phi. So just relate the formulas and find your rho, find your theta, then find your phi. But remember, theta is the same. When converting from cylindrical coordinate to spherical coordinate, your theta remains the same. It doesn't change because you can even see that theta is here. It is not changing. Theta is also in the middle here. It is not changing. So it's the same. So the angle here, pi on 4, will be the same for our answer in spherical coordinates. So only the z and r will change. So the r will change to rho, and then the z will also change to phi. Okay, so we are finding the relationship between z and phi, and the relationship between r and rho. So this is the relationship between r and rho and z. So you use this relationship to find your rho, and you know that rho is called square root of r square plus z square. So you just make a substitution. This is your r, so root 6 square plus this is the z, so root 2 square. So you are going to get root 8. You can leave it like this, or you can further simplify, because here you are going to get 4 multiplying root 2, and which is 2 root 2. Okay, so you've gotten your rho. Then you ask yourself, what is the relationship between z, rho, and phi? And this is the relationship. Okay, we have done this already. We have proved them already. So no worries. So just make a substitution and make your phi the subject to, because you know your rho to be root 8. You know your z from the question. This is the z. So just make a substitution to find your phi. So you are going to get phi should be cos inverse of half, right? So cos inverse of half, you are going to get 60 degrees. But remember, always look at the question. When the question is given in terms of radians, like pi on 4, leave your answer to in terms of radian. Or if the radius is in root, leave your answer in terms of root. Don't leave your answer in terms of points. So always check the question and know how they root it. So when you are done solving, you also represent or present the same thing. Okay, so here the radius was in root, so that's why I left it in root, in terms of root. Then we know that for the theta it will be the same, but for the z it is in root 2. But then when you find phi, we are going to get 1/3. The reason why I didn't leave in 60 degrees is that the angle here wasn't in 60 degrees, it was in radians. Okay, it wasn't in degrees. So you need to convert the 60 to radians, and by doing so, just divide by 180, the answer by 180, then multiply by pi. Okay, so we are going to get 1 over 3 pi. So you've gotten your phi. Then what's next? You are done because you know your rho, you know your phi, and theta is the same, which is pi on 4. So you just represent it like this: 1 over 3 pi, comma, pi over 4, then 1 over 3 pi. Okay, so thank you very much.